Let's do some operations. Addition, subtraction of matrices. Matrices of the same order, that means the same size, are added by adding the elements in corresponding positions. Matrices of the same order can be subtracted by subtracting the elements in corresponding positions. A matrix whose elements are all equal to 0 is called a zero matrix, and the m by n zero matrix is called the additive identity for m by n matrices. Let's jump into example 4 and perform the indicated operations. We're going to be adding, and we need to have the same order. So this is a 2 by 2 matrix, and this is a 2 by 2 matrix. Therefore, we can add, and all we need to do is add corresponding elements. So -4 plus 6 is 2. 3 plus -3 is 0. 7 plus 2 is 9. And 6 plus -4 is 2. Example B. Let's check the size first. The order is a 3 by 2, and the second matrix is a 3 by 2. Therefore, I can subtract like I'm being asked to. I wonder if you're thinking about if the size was not the same, could we add and subtract? The answer is no, you can't do it, so our answer would be undefined. Like I mentioned, in this case, the size is the same, so we can subtract. Let's do it. 5 minus -4, that is a negative and a negative, which is positive. 5 plus 4 is 9. Don't forget your minus in between every operation. So now I have 4 minus 8, -4, -3 minus 6, -9, 7 minus 0 is 7, and 0 minus -5. That gives us positive 5, and 1 minus 3 is -2. A different way you can do this, if you felt a little overwhelmed by the negative, is that we can distribute the negative. So we can rewrite the second matrix. And so instead of me saying 5 minus -4, I can distribute this negative into each and every element. And you're going to see that in the next section with scalar multiplication, and avoid a potential mistake. So I have positive 4, -8, -6, 0, positive 5, and -3. And so your answer should be exactly the same as we just discussed, but I feel that it makes it just a little bit simpler. 5 plus 4 gives us that 9. 4 plus -8 gives us that -4, and so forth. Scalar multiplication is another operation with matrices, and what we do is we multiply a given number into the matrix by multiplying the number times each element. Example 5a. We have -6 times matrix B, going to multiply -6 times -1, -2, 8, and 5. Going to multiply -6 to each element. So we're going to essentially do 4 multiplications. -6 times -1 gives us positive 6. -6 times -2 is 12. -6 times 8 is -48. And -6 times 5 is -30. Don't forget to put your brackets around this. And that is your resulting matrix. Example 5b is just a tad longer, and it includes 2 operations. There's a scalar multiplication and there is an addition. 3 times A, negative 4, 1, 3, and 0, plus 2 times matrix B, negative 1, negative 2, 8, and 5. We are going to multiply first. Let's get you into each of these elements. Let's get this 2 into each of these elements. And so we have negative 12, positive 3, 9, and 0. Negative 2, negative 4, positive 16, and 10. Now we can add. I'm going to make sure that I have the same order. Let's put these corresponding elements together. Negative 12 plus negative 2 gives us negative 14. Don't forget your brackets. 3 plus negative 4. 9 plus 16. And 0 plus 10. Example 6. We jump in and put everything together. It says, given the matrices below, answer the following questions. And I see matrix A, matrix B, matrix C. They're going to ask me to compare, so I'm going to give everything the order. Matrix A has 3 rows and 3 columns. It is the order of 3 by 3. Matrix B has a size of 2 rows and 3 columns. Matrix C has 2 rows and 3 columns. Question A, is A equal to B? Remember that we have to have the same order and the same elements. We do not have the same order, so this is false. Question B, I'm being asked to add after I do the scalar multiplication. And I can already see, and hopefully you can as well, that matrix B is a 2 by 3 and matrix A is a 3 by 3. And we will not be able to add these because in order to add, we have to have the same order. So this is undefined since I won't be able to add. I didn't worry about the scalar multiplication because I wasn't going to be able to add anyway. Let's look at B plus 2C. What's the order of B? 2 by 3. What's the order of C? 2 by 3. Will I be able to add? Yes. So I'm going to carry out the operation. Negative 3, 0, 10, 2.5, and 8. Plus 2 times negative 3, 0, 10, 2, 1/2, and 8. This matrix did not have a scalar multiplication, so I rewrote it. The second one does have a scalar multiplication. This is negative 6, 0, 20, 4, 2 times 1/2 is 1, and 16. We had already checked that they were the same size. Let's go ahead and add corresponding elements. We have negative 3 plus negative 6. Zero plus 0, 10 plus 20, 2 plus 4, 0.5 plus 1, 8 plus 16. And that is your answer.